Welcome to MyProjectBazaar.com. Our product title is Trip Point Bitline Precharge Sensing Scheme for Single-Ended SRAM. Now we are going to discuss about our product abstract. A Trip Point Bitline Precharge (TBP) sensing scheme is proposed for high-speed single-ended static random access memory. This trip point bitline scheme mitigations the issues of the limited performance, power sensing and margin and area found in the previous single-ended SRAM. A SRAM scheme by biasing the bit line to the single layer value of the trip point of the sensing amplifiers. The simulation result so that the component of the domain acceptedly compared to the sensing scheme. In the SRAM takes up the large portion of the system on chip. In addition, total power consumption of SOCs is dominate the leakage and dynamic power of SRAM. Although using the small size transistor and powering supply voltage can reduce the SRAM area and power consumption, the SRAM is significantly degraded because zero storage node increased bit line charge injection during the read operations. The address is the SRAM cells with a separate read path were introduced such as 80 SRAM in our proposal. The stored data in the 80 RAM cell is read by the detecting the read bit lines and write bit lines is asserted. When select the SRAM cell stores the data zeros, which means the write storage node stored 1. Current flow through the read path and voltage because low. If the selected SRAM cell stores 1, the RBL voltage remain high. By maintaining the voltage that is the close RBL pre-charge voltage, the speed of the single-ended sensing is increased. Important modern process of the single-ended schemes is limited. The performance of the domain sensing scheme is severely degraded. The number of cells in the bit line on the large, it takes the long time of the SRAM cells full discharge of the large RBL capacitance. Now we are going to discuss about our product flow diagram. So this is our flow for this, the designing of 80 SRAM cells, and then we selected the right word line WWL. This process for the enable give the input process and the cross interaction logics. This process we are going to give the bit line right. First of all, give the right and then a right enable pin WLL, and then we are going to design the read path. So whatever we give the input and that process which time it will be give the output, so we are giving the logic of the enable pin. After going to that we single ended the logic. In this logic we are the whole process we have give the enable. At the same time we give the one path of right line we give the input and the enable pin. This process what time we give the input for the only the right line, and then the single ended path design fully means it will the sensing the whole 80 schematic diagrams process, and then we get the read line for the RWL. This process water time the trip point with the inverter and transmit the gate to increase the sense of the amplifiers, and then read bit line the RBL which give the number we give the right, and then we give the read and the pause of the process. Overall, this sensing amplifier the trip point of inverters the transmit the gates on to the TBP sensing scheme to the LLB self. This read path we single ended the path we control the one schematic logic of the process. This read path we consider the one limited for the each and every bit lines of the store, and they get the value of the 80 RAMs levels in the storage of the logic functions in ICs. Now we are going to discuss about our product running processor. This is the Tanner area tool for the 13 versions. Here I hide the designing process, and then here the list of all process we have done and the process whatever the time when we have given the name, just open it, the design is open, and then we are going to the so cell 0, select the cell 0, and then we select the process for the hierarchy cell 0, open the cell zeros, and then running the procedure and the running the setups also. Here the simulation setups, the transients Fourier analysis, we select the for reference this process, and then give the stop time. The stop time we give that 200 nanoseconds and 1 nanosecond, and the print time setup for the zeros, and then the usual initial conditions false, and the startup mode is open. This is the simulation setup. This is a given setup closed. After we are going to the simulate the process design process. This is the output for the S8 SRAM process. This is the RBL, RWLL, and then this is the WWL. So this is the bit line for what are the we give the input functions for the bitwise, and then this is the enable functions RBL. This process the enable at time we get the output for the write the bins. So what are the time of we give the input process, we give the output process in the bit lines. This process, and then we are going to using the power calculations. The power classes we are using the Tanner, and then UT spaces. So what are the we get the ICs, the power consumption we using the process in the systems.